to introduce you our first speaker. His position is called Community Advocate, but I would rather say he's taking care of users and developers. Long story short, greet Emanuil Tolev, our Community Advocate at Elastic, with his presentation on the topic Live Kubernetes Debugging with the Elastic Stack. Hello, Emanuil. Can you hear us? Can you see us?
Yes. Perfect.
Great.
Thank you very much.
How are you? How do you feel about this conference?
It's fantastic. I'm very glad to be here. It's super exciting to be able to do a conference in Ukraine from my home in London. That's great. Thank you for having me.
Thank you for attendance. And I think first thing first, you are welcome to start your presentation. Good luck.
Perfect. Thank you very much. And thanks to the audience for all being here for this. So let's get started, folks. We have quite a lot to look at today. So let's dive right in. So the topic is, as Alex said, live Kubernetes debugging with the Elastic Stack. And my name is Emanuil or Emanuil. I'm a community advocate for Elastic indeed. And that means that basically I try to figure out what problems people are having in their daily life as developers and write talks that show you some solutions. So today we'll be looking at the simple application, the sample web app that comes with, or one of them that comes with the Spring Java web framework, Kubernetes, and it is this application. So imagine that you are perhaps an employee for an agency or consultancy, and one of your clients is this small veterinary clinic. So you are maintaining many websites on your infrastructure, and this is just one of them. So here you can look for pet owners, and you could look for specific people. You have a list of doctors that are employed, and like any self-respecting demo, you can also generate an error. Very simple, and you can also click into owners and update their personal details. That's it. So we have very, very simple app. Now for the background, like the architecture of it, and we essentially have a client side that talks to Node.js and in the backend, and Node.js passes traffic onto the main backend, which is written in Java, and to a small service written in Flask, in Python, the Flask web framework. And they use some data stores in the backend, MySQL and Elasticsearch, but for today, we'll mostly focus actually on the Java backend. So if you haven't heard of the Elastic Stack before, it's very, very famous for its use in web service monitoring and observability setup. At the heart is Elasticsearch, an open source analytics and search engine. So what that means is you can throw text and numbers at it, and it will return answers to your questions very, very quickly. And it's good at time series data. And so is Kibana, the graphical user interface. That's the thing you see on top. And so today we'll be focusing on Kibana and beats mostly. So what are beats? Beats are at the bottom of the stack. You can see them right here. Beats are little daemon background programs that collect useful information like logs, metrics like CPU and RAM. They take almost no resource to run, which is the point. They're data collectors, and so they run on your actual production setups. And that's a bit more tricky to do in Kubernetes, as we will see today. Then finally, Logstash, which we will not be dealing with today, is a powerful configurable log parsing engine. But today we'll focus on deploying the beats for getting logs and metrics out of Kubernetes. And then there's one more component, that's on this diagram, that's application performance monitoring or code tracing. So we will see metrics, we will see logs, and we will see code traces and how to do that in Kubernetes with an app. And you can download all of this yourself. And actually, all the functionality I'll show you today is completely free to use. Data store, graphical UI, data collection, everything included in there. You can download all of it, run it. As a commercial company, there's no time trial period or anything like that as a limitation. But if you get tired of running your own monitoring setup, you can also run it on Elastic Cloud. Here you can do things like fault tolerance using a slider, which is definitely more convenient, I found personally, in my work than setting up fault tolerance yourself and high availability. And you avoid the problem of who watches the watchers. Once you have your Elastic Stack running, like how do you diagnose problems with it and then keep it running? But some people do decide to run this in-house, and that's also a perfectly good option. So, demo time. Basically, your boss comes to you and says that they received some complaints this morning that yesterday evening the veterinary site was very slow to use. So the clinic was slow. I don't know exactly when, but it was after you all went home. Okay, so let's have a look. First off, you can try it now. That's what we all do, and somebody reports an intermittent problem, which is the most annoying type of problem. Okay, it's fast right now. Okay, that means we have to look at some historical data. So first off, when you open the graphical user interface, Kibana, here on the side, you will see a number of little icons, the apps that it supports, this machine learning and tons of other stuff. But today we'll look at metrics, logs, and traces. So let's say first you decide to look at the metrics to see if it's a resource issue. Okay, so we're looking at the metrics. And okay, we can look at specific times, but we just don't have that much time today to play around. So here there is a time picker though, so you can see historical metrics. Okay, so here we're seeing the hosts, where the nodes in the Kubernetes cluster, where all of the container pods are running. And we can see, okay, there are some that have higher CPU, but nothing is maxed out. We can also look at RAM. Yeah, okay, that's again not a problem. Then let's say that, switch back to CPU. And let's say that we actually don't want to see the hosts, because okay, that we can get that data pretty easily in other ways. But let's look at Kubernetes pods. Okay, so this is a bit more interesting. So we see individual pods here, and we can immediately see which ones are hotter. And we can see down here the maximum value, which is 20.7%. Okay, so none of them are using that much CPU. So it's sort of looking like this might not really be the problem. Now, however, what I want to show you is, because like, okay, a bunch of boxes is just not that useful, but we can go further than that, and we can group them by namespace and service type. So, actually the other way around, by service type first, and then namespace.
Emanuil, can you hear me?
Yes.
It looks like you've got some issues with the presentation. We still see your browser screen.
Well, you should be seeing the browser, yes, but just a different tab.
Thanks.
What are you seeing at the moment?
Oh,
Let's see. Is that working now? Or?
Yep.
Yeah, looks like it's... okay.
Sorry. You can
All right, okay. Great. Also, I didn't have to do anything, so this is my favorite kind of problem. It just fixed itself. Okay, yeah, so this is, so remember I told you, imagine you're like running you're an employee at an agency or consultancy, so you're running multiple things, so when your boss tells you, you don't exactly maybe remember where this stuff is running. So this is super useful if you have multi-tenant setup. Of course, if you have only one app, then it's useful again, but just a bit less so. But it essentially just provides a map of your infrastructure. So here we have, remember we had these Nginx instances, and here we can see them. And we have the MySQL instance, and so on and so forth. All right, so that's great. Like we can get a map of our infrastructure, but it's okay. It just that in this particular case, we're looking at data from last evening, but it's not telling us that there is an obvious problem. Now, if you click into any of these boxes, you will get a view like this. So you'll get CPU usage, memory use for a specific pod, network traffic, and actually if you have Nginx running on that pod, you will also get Nginx specific metrics, which is pretty cool. Okay, so how do you set this up? Because the point isn't just to show you the user interface and pretty graphs. So first off, all this information is collected using metric beat. It's a little program written in Go that will usually collect information from your virtual machines. But here it's collecting information from Kubernetes. All right, so how does this work? You can collect information from outside the cluster with metric beat by giving it the specific config, or you can run it from inside the cluster, essentially in what's called a sidecar container setup. So first off, we'll look at the necessary configuration for metric beat, and then I'll show you the daemon set. Because the way to run metric beat inside a cluster, alongside your apps and all the other stuff, is with a daemon set. Yes, it is a daemon, that makes sense. Okay, so for its own configuration, the most important thing that you need is this metric beat autodiscover, and then the Kubernetes provider. So this means that it will go away and try to spider out locally in its own little container encapsulation and its own little container garden. It will try to look at specific paths, and it will assume that it's getting a host and cluster information there. But I'll show you how to make it actually retrieve that information. And furthermore, it's useful for you to know that with these templates, you can give specific conditions so that for specific containers, like in this case, Nginx containers that have this label that we've given, this is just a custom label we've given the container in Kubernetes setup. For there, we want to retrieve these extra metrics. So we tell metric beat, configure yourself only for those containers to have this extra config. And that's how we got the Nginx stuff that I was showing you earlier on the individual pod graphs. Okay. So the way you configure what you want to get out of your system is, of course, using configuration. So first off, the system YAML you configure for metric beat. This is the hosts that you saw in the very beginning. So this is like your actual virtual machines, CPU, load, memory, network, and so on. And inside Kubernetes, you tell it, okay, get the Kubernetes module and retrieve pod, container, system, cluster-wide diagnostics, and so on. And you can also retrieve the raw Docker diagnostics. And you get this from a Docker socket. All right. Okay, but this is all configuration, right? So how does metric beat that's running in this encapsulated little container actually get access to all of this data, some of which is only accessible to root? Well, this is where the daemon set comes in. Right? So in the daemon set config, what you need to do is mount this information from each Kubernetes node into the metric beat pod. For example, you give it the proc file system, the most important one for system-wide metrics. You give it C groups, where it can see how the resources are being divided. And for Docker information, you give it access to the socket. So that is it. That's the most important thing. And all of those files you will be able to get from a link. I have a slide with all of the necessary links. And I will also give the important link to the organizers to share with you. So don't worry, you will see all of the files. Now, we didn't, that didn't really go anywhere in terms of solving our problem. Because, okay, we got some information from metrics, but in this case, it just wasn't a resource issue. So we didn't see, we didn't get to a resolution of any kind. So let's look at logs. So we selected here a specific time frame from 6 to 11, because the 6 is when you, or 5:30 is when you leave work, and there was no problem then. And it was in the afternoon when people were still using the clinic website. So, okay, we'll look at that. So what can we look at first? Again, you have a lot of applications that are giving their logs, that are putting their logs in Elasticsearch using FileBeat, and we'll see how to set that up. But how do we even begin? Well, here you have, in Kibana, you have field name autocomplete. So we're looking for maybe some kind of error. So I would guess that there would be something that's to do with status, like HTTP response codes, either status or response. I would start writing. And indeed, in the autocomplete for the field, you get this. So even though you might not be that familiar with exactly what the field names are called, nobody remembers that all the time, or because you have 30 apps running, you just can't quite remember. The tools try to help you with that. Okay, and of course we know that error codes start at 400. They're in the 400s and 500s range. So I'm gonna say, give me errors. Okay, this is a lot better than 1.6 million, 1.5 million records, but it's still quite a lot. So let's have a look at just the first one to see, okay, what are we actually getting in here? We have a ton of information in here. Aha, here. Okay, so that's a 404. That would be a not found. Okay, so that's probably not so useful. And the way you can negate a condition in Kibana is saying not before it. Okay, so then I again want the same field, and this time I want a colon. So now we're saying, give me all errors, but without 404. And we hit update. And now we get, okay, 163. That's a lot less. And these are all more specific errors, and there's even a spike. So that could be useful. So let's see what the first one is. Let's start exploring. Okay, so this is event module, says it's Nginx, and the dataset is access. Okay, so this is part of access logs. We're getting a 499. This is a custom Nginx error code that it likes to use. Okay, let's exclude Nginx for the moment. Okay, so we saw that it was in the event module category, or the event module field. Now, one cool thing here is that the Kibana not only autocompletes field names, but it actually autocompletes values as well. So here you can see two possible values for that field are Nginx and MySQL. And it will give you the top 10 values that are relevant for your query, which is really excellent for exploring. Okay. Yeah, okay, 15 is better. Okay, so now we will be looking at some errors, hopefully not from Nginx, but from other containers. Now, I want to take just a second here to draw your attention. Zoom in a little bit. Okay, so you see here it says cloud, and here we have container labels, and here we have host. There's a certain prefixes that are included. And here we have even Kubernetes information, like the labels, the namespace, and so on. And I want to draw your attention to this because it's, I want to show you later how you can add all of this information automatically to every log message that is sent out, because that's exactly what allows you to do the kind of thing I did just now, to slice the information in different ways and to filter it down very quickly. So we'll see how to configure that in a bit. So here we see we have a put, and there's a 400. So that's a bad request. And it came from the front end. Okay, so the front end, so this is the actual log message. So it looks like it was an update, because a put is usually used for an update. And it was a bad request. But most important and most interesting is the time it took. So this took nearly 13 seconds to complete. Okay, and if we look at the next one, That took 18 seconds to complete. All right, so now let's say that I wanted to look at more of them at once. And this sort of view like you have here is just not very easy to read. Look at this. It highlights the field names, but it is hard to read. Okay, so what can we do about that? So actually we can call out specific fields. So for example, let's say I want the request method, and let's say I want the status of the response, and let's say I want also the URL. Okay, so now if I collapse one of these, although now I get the summary view of all of the errors, and it appears that all of them have to do with updating an owner. So this is now quite useful information. So why is the problem that things are taking so long? If you have a standard setup where you have synchronous web workers, you're going to have a serious problem because usually a request comes in and it's answered in 100 milliseconds, 200, 500 even, but not in 20,000 milliseconds. And you would usually have, I've run an app that was fairly popular that had like 8 web workers, and then later it expanded to 16. So if you're getting these, and this is a multi-tenant setup, it has a lot less resources because it's some small business's website. So presumably you've given it a lot less. It's a huge problem then, because while a web worker is busy answering one request, it will not have time to answer all of the little ones that would take 50 or 100 milliseconds. So it's hung up, it's busy, just like a phone line. So this is a problem. So we need to investigate. But this is kind of where we run into a limitation. Okay, with the events that we've logged, this is as much information as we've chosen to log at the time. And so we can't really go forward anymore. Okay, now we can, of course, go to the to updating an owner and try out some things and see what happens. Or look at the code there, just try to reproduce somehow. But we don't really have more information. So we'll continue this investigation in a second. But first, let me show you how to actually get all of this information. So again, similarly to metric beat, here we're going to use FileBeat, which usually takes log files from disk and sends them to Elasticsearch. Here, of course, it's not from disk. It's from Kubernetes. So we have here the most important thing. We're going to start with the configuration, and then I'll show you how to run it as a sidecar container. And in the FileBeat configuration, most important thing, again, is the auto-discover property of type Kubernetes. And then, so that's all that you need to set initially. Then if you want to specify behaviors for individual containers, you can do the same as I showed you in metric beat. You give it conditions, and you say you give it some way to filter the containers down. So in this case, it's a custom label called infrademo, and type is nginx. Okay, and then for those, you tell it for the nginx logs, this is how you access them. All right. Then in another part of the configuration, so remember how I showed you down here in specific events, how you had stuff like the cloud provider, like even the machine type here, and stuff like the Kubernetes metadata, all of the metadata from the cluster. So how do you add that to every log message? So you add it in the processors section of the FileBeat config. So you add cloud metadata, host metadata, and Kubernetes metadata. And for Docker, we will talk about that in a second. Okay, and the important thing for the Kubernetes metadata is that if you're running FileBeat alongside your apps inside the cluster, then you want to say in cluster true. All right, but so this is the config. That's how to tell FileBeat to output something like this that looks like what I showed you. But then we have, again, this problem. FileBeat is running in a sidecar container. It doesn't have access to the logs of all the other containers, right? Okay, so we need to give it access. So again, we have a daemon set because it's a daemon. And then at the very bottom, we have the volume definitions. And here you can see for every Kubernetes host that's going to be running your pods. So for every like big virtual machine running these pods, we need to give FileBeat access to the other containers. And that's how we do it. We literally just give it access to var lib Docker containers. Combined with FileBeat autodiscover provider Kubernetes, it knows to spider out, like to go in its own local file system to try var lib Docker containers, and then to spider out and look for files and then set those out and send them to Elasticsearch. And for Docker related information, you again need to give it access to the local Docker socket, and it will do the job from there. So a lot of this is to do with automatic configuration and sort of conventions of where files are and where you could take metrics from. And as a vendor, we have built that in to those daemons. And again, don't worry, you can get those files, those sample files at the end from the links I have. But let's continue with the investigation because we're, well, very close to time, a bit closer than I would like. So the final piece is code tracing. All right, so they're kind of low on time. Let's jump directly into the backend because we saw that it was a call to the backend, and basically the backend responded slowly, but in the logs, we didn't really know why. We're using the same time frame as before, 6 to 11 p.m. So that I've clicked into here, and you can access all of this on the side, by the way. So metrics is in here. The logs, I use the Discover user interface to slice and filter them down. And then for tracing is over here. It's called APM, Application Performance Monitoring. Okay, so then we click into the backend, and this is what we get. Pretty standard display for a code tracing system. Most interesting stuff is down here. So transaction duration, a throughput, and then the top transactions that are that are the slowest, both by how many there are and by their speed. So there are some spikes here in the back, so you can also zoom in. And once you do, we see some interesting information here. We already got some idea about this from the logs. You know, we saw that about after 10 p.m. there was some really slow requests. Okay, so we can see here, yeah, there are 20-second spikes. There's about 3 of them. And now this update owner transaction is showing that it's very slow. On average, not so slow because there are still many fast ones, but the 95th percentile tries to, it's a statistic method, it tries to show you to gather outliers, so give more weight to slower transactions. So it's to show you what 95% of users might be feeling rather than just on average. Okay, so let's click into that. If I click into that, I would get something like this. Okay, so this is an APM typical code tracing breakdown. You can see even specific transactions. It's not so interesting. Okay, yeah, and you can see exactly what line of code issued that transaction. But this is one of the most useful parts. So there are samples here of 10 normal transactions that are between 0 and 1 seconds. And then to the right in this bucket, we have problematic ones that took over 18 seconds. And what we can immediately see here is that update owner actually ran really quickly, about 1 millisecond. Then validate zip code, that function in the Java code took nearly 20 seconds to run. And in fact, if we click on the error, we can see that it says this is an invalid zip code. Okay, so it's very long and it's kind of weird. And I can show you because we're pretty much at time. I'll show you the code for that. So from the APM system, we get the exact code line. Yeah, okay, this is line 30. And if we go to line 30, that's just the exception catch. And the only other piece of code here is this. Okay, so it's too complicated for regex. So when you try to run a small zip code or a valid one, it completes successfully. But if you try to run something ridiculous like I showed you there, this is an American zip code, so it doesn't allow characters, it doesn't allow letters. But so this is a really complicated way of saying, give me a 4 or 5 digit number. And when you give it a very big number to try with letters inside it, it just runs really slowly. So that's what's happening here. So we found the problem, and then I'll just show you very quickly how to instrument this. Okay, so because this is Java, all you need to do is when you're running your app, instead of running your jar, you run the Elastic APM agent jar, and then you give your jar as an argument. So it's like an envelope that goes around. And this is actually all that you need to do in order to get all of this information here. Like that is it. For this application, that's how it's done. And if you wanted to do it for your front end, you would, and for many other languages like Ruby and Python, you need to include it as a dependency like in here. And so in your package JSON, this is a React app in this case for the front end. And then you would just need to say init APM, give it a name, a URL of APM server to send the information to, and then you're done. So you have an APM client that I'm showing you here, both the Java version and the JavaScript. They send information to an APM server, which could be running on Elastic Cloud, or you could run it. That sends information to Elasticsearch, and then we look at the information there with Kibana. That's the setup. Okay, so that's everything that I wanted to show you from the demo. And basically, in conclusion, I want to tell you, what we have here is you go from seeing individual containers or individual components of your app as an island to seeing the overall map. That's what our stack tries to get you to do. And that's why, like in the metrics, we have all of those little blue cubes. And that's the point of overview, transactions in the APM system. It's also the point in Discover. No matter how complex your setup, you can drill down the data in whatever way you choose. So then this is these are the links, and I will make sure that they also get to the organizers. The very last link contains the beats configuration that I have been showing you. And the tutorial is also that I have in the second link is also really, really straightforward for you to set up. And you can also see a version, not this exact demo, but a version of it at demo.elastic.co, like just if you want to play with the UI. That's it. So thank you very much for listening. Spasiba. And,
many thanks to you.
Yeah, stay safe and stay healthy.
It was really interesting.
Cool.
But unfortunately, we don't have a lot of time for your questions, so we can ask only a few of them, and the other one will be asked only with our chat, okay?
Yes.
Okay,
yes.
so
thank you a lot for the
move
opportunity.
further to our questions. I think there is only one or two of them. The first question is, does Elastic Stack is a winner in competition in the title of Best Analyzer of Security Logs?
Best analyzer of security logs. Okay. So that depends on what you mean by that. That's quite a general question. We have moved into security recently, and I would say that we have quite a good solution already, especially given that a lot of it is free. Like you can get, it's a combination of workstation security or server security. So you get anti-malware stuff, like you would run on your computer, but for servers, you get a combination of that and the SIEM, which is the Security Information Event Processing System. This is like for perimeter defense and indeed security logs. So about being, I guess that's what this question refers to the SIEM. Mm-hmm. I think it's a good product, genuinely. I think you should try it out, especially given that the SIEM is completely free, unlike other competitors. But there are also a lot of features that still need to be developed because we are a new entrant to the market. So I will be honest about that. Whether it will do what you need, I would encourage you to go and have a look. But there are systems with more features out there. It's just a question of, do you actually need all of them when you're paying for them?
Okay.
So that's a trade-off.
Thank you. It was really interesting. And I want to tell you only just a few things. Thank you. It was a really great, interesting presentation, as for me at least. I want to say that According to our tradition, we want to give to our gift box and our conference mascot. We will send them to you later. So I hope they will
Awesome.
remind you about our conference. And I hope we'll see you next year already offline.
Yes, I hope to come back to Kharkiv. I've been once before, and it's a wonderful city. Reminds me of Bulgaria, where I grew up.
Hope we'll see you yet another time. Thank you, Emanuil, and I think we can now move on.